We'll talk about set theory. So actually, before we come to set theory, we need another building block down here, and that will be logic. Set theory. Now, once we have the axioms of set theory and we have our beautiful sets, the question is, what can we do with them? And one thing we certainly need, at least for these four subjects, we need a notion of continuity. For instance, in classical mechanics, famously, particles don't jump. So the particle trajectory doesn't stop somewhere and start somewhere else again. It's continuous. So you need a notion of continuity. And such a notion you get by distinguishing certain subsets of the basic set you have. And that leads to the notion of topology. I'm going to write down are the interesting ones, but from the point of view of theoretical physics, immediately interesting are the topological manifolds. Topological manifolds with a D. Now, that's not enough. If you have topological manifolds, you also need, in physics, especially in classical physics, you need a notion of derivative. You need to be able to talk about the velocity of a curve. And that cannot be done in topological manifolds. What you need there, you need differentiable manifolds. And that, once we have differentiable manifolds, maybe already before, we'll come to a notion which, well, in some sense, is yet another structure, but it's bundles. So once we have bundles, or maybe also alternative to bundles sometimes, so don't take the picture too seriously, it's a rough idea of how this building is constructed, we'll have geometry. Geometry comes in form of so-called tensor fields on this structure. So that could be symplectic geometry, that would be the geometry of classical phase space in mechanics, but actually it's a much bigger subject because for virtually all dynamical systems of interest to us, the phase space is equipped with the symplectic geometry. There may be a metric geometry. This is certainly the case in electromagnetism. You, to a certain extent, need a geometry, you just need a volume form. And certainly it's the case in relativity, and especially in general relativity, you need a so-called Lorentzian metric. This is a structure that sits on top here, but you need to understand more or less all of this in order to really professionally deal with geometry. Well, and then to complete this, then what I promised you, that all these different subjects you learned about before, so up to here, it's just mathematics, but then up here it's physics. You have classical mechanics, electromagnetism, quantum mechanics, statistical physics, and special relativity and general relativity. All of these physics can be understood and can be properly understood by mastering all these mathematics.